Hello everybody. Today on LeetCode, we will be solving LeetCode medium difficulty question number 1663. Smallest string with a given numeric value. We will be programming in Python. In this video, I will go through the steps that I took to get to an acceptable solution. Throughout the video, if you feel like my pace might be a little bit too slow or too quick, feel free to skip or pause on any of the sections that you need. Let's get into it. The numeric value of a lowercase character is defined as its position in the alphabet. So the numeric value of A is 1, the numeric value of B is 2, and the numeric value of C is 3, and so on. The numeric value of a string consisting of lowercase characters is defined as the sum of its characters' numeric values. For example, the numeric value of the string ABE is equal to 1 plus 2 plus 5 equals 8. You are given two integers, n and k. Return the lexicographically smallest string with length equal to n and numeric value equal to k. Note that the string x is lexicographically smaller than string y if x comes before y in dictionary order. That is, either x is the prefix of y or if I is the first position such that xi does not equal yi. Then xi comes before yi in alphabetic order. Okay, so I think it's important to first just make sure you understand what it means for something to be lexicographically smaller. For those of you who don't know what that term means, if you have the experience of physically flipping through a dictionary to find a word is lexicographically smaller than another if that word is closer to the start of the dictionary. If you don't have that experience and you still don't know what lexicographically smaller means, I would suggest you reading the definition here. If you still don't understand, make sure you find a way to understand what it means, because if you don't, you can't solve this question. Okay, so what I'm going to do now is I'm essentially going to use this whiteboard, and I will try to basically visualize to you guys what I have in my head, what my thought processes are. So what are we trying to do? Well, this is what we are trying to solve for. We are trying to find the lexicographically small string with length n and numeric value equal to k. Let us just box this, end goal, so we can always see what we're trying to do. Okay, so what else do we know? Well, what are the numeric values of the characters? Okay, A is 1, B is 2, C is 3, and so on. Okay, let us write that down. A is 1, B is 2, and so on. All the way to Z equals 26. Okay, so in my mind right now, I'm trying to imagine the super big set of strings of size n that I can construct using lowercase. Oh, red might not be a good color. Let's make it black. Okay, so right now, in my head, I can see all the strings of size n that I construct with lowercase alphabetical characters, right? In total, there's total of different n to the 26 different ways, right? And for each of these strings, there is a corresponding numeric value associated with it. And what can the numerical value associated with each string be? Well, it has to be between n and 26 times n, right? The smallest string that I can get is just the one with all A, so 1 plus 1 plus, n times. The biggest one is all Z, so 26 times n. Very simple. Okay, now what I am imagining is if I could somehow, split this super big set of strings into corresponding categories or groups. And what are these groups? Well, these groups are essentially the following. Two strings are in the same group if they have the same numeric value. And then let's sort these groups by numeric value. So what we have here will be, the smallest numeric value possible, and what we have here will be the biggest possible numeric value. Okay. So again, our question, what we're trying to find is to find the smallest string with length n that has numeric value equal to k. So let's just say this is the kth box, right? This lexicographically small string in this box here would be our answer. Well, how do we find this? Well, I think it will be if you haven't realized the pattern now, you will soon see the pattern. Okay, so what is the string that goes into this group? Well, in fact, there's only one string. Like we said earlier, it's a string with all A's, right? What's the string that goes here? It's a string with all Z's. If I decode A into numeric values, what do I get? I get 1, 1, 1, 1, 1 all the way. Let me just, this will probably. What do you think is the lexicographically smallest string of numeric value n plus 1? which is the lexicographic small string in this box over here. Well, isn't that just this? The last character has to be a B. And if we decode that in numeric values, what we get is a 2. Can you see the pattern now? What we're doing is essentially we just add 1 to the rightmost character that is not yet a Z. And to find the kth, to get to the kth, not kth, but group, to get to the box K, what we have to do is essentially do this add 1 step, K minus n times. Eh? You see where I'm going now? Okay, let's try to code this up. Okay, so how many times do we have to do this add 1 step? Well, we have to do this K minus n times. Okay, let's call this, let's store this in a variable, steps to take. Well, that is K minus n. Okay, so while I have a while loop, basically, that says, well, I still have more steps to take, I have to do some action. So while this is not equal to 0, I am doing something. And then at each step, I just need to make sure I decrement it by 1. Okay, so remember how I'm saying we add 1 to this starting string here, and we just keep adding 1. We add 1, we add 1, we add 1. Well, the starting string can be encoded the following. Let's say the start is equal to 1 for I in range n. Okay. And what was the adding step that I said earlier? We basically find the rightmost character that is not yet a Z, and we add 1. Z is also equal to 26, right? So what we're trying to do is we make sure that the rightmost character is not at 26. So let's keep track of the rightmost, not 26. So this should be n minus 1 in the beginning, right? If the rightmost, not 26, is equal to 26, then we know we have to essentially shift 1 to the left. This is the case when, let's say I encounter something like this. Right, the next one step that I take will result in the following. Okay, so I need to make sure that I, move 1 to the left, and then I just need to simply add 1. And then at the very end, I need to translate. So right now, what I have are the numeric values. I need to translate from numeric value back into the alphabetical characters. Okay, so let's call this the decoder, and there's probably a quicker way to do this, but right now this is what I have on the top of my head. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. Okay, the reason why I have a space here is because, it's one indexed. Okay, so let's say my solution string is start with the empty string, and I simply just go through my start and then just add, the corresponding character, and then I return it as my final solution. Let's see if this works. Ooh, what did I do here? Step to take. Oh, yes, I forgot to add the S. Syntax error. Very, 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 very careless of me. Okay, so I believe it should work. As you can see here, I've already done this question before, so hopefully I should get this right. If I don't know. Okay, so we have it right, and as you can see, there's one thing you can notice though, is that we can speed this, solution up by a constant factor. I don't think there's a faster, there's a faster than O of n algorithm, but there's definitely you can speed up a constant factor, and here's the thing you can speed up. So you see here how we're only adding by 1 each time. We can actually basically speed things up by adding it by a minimum of 25 or the remaining steps to take. Note, this will speed it up by a factor of, I believe, 25, 26, somewhere around that. Okay. So this is it. And, this is the first video I have on a series of LeetCode questions that I will, be uploading daily. If you have any specific questions that you want me to go through, leave a comment below, leave a like and subscribe. I'll try to upload new questions every day. So hopefully this could be of some use for those who are trying to prep for CS coding interviews. And as a wise man once said, a LeetCode problem a day keeps unemployment at bay.